This is the story of the one. As head of maintenance at a concert hall, he knows the show must always go on. That's why he works behind the scenes, ensuring every light is working, the HVAC is humming, and his facility shines. With Grainger's supplies and solutions for every challenge he faces, plus 24/7 customer support, his venue never misses a beat. Call quickgrainger.com or just stop by. Grainger, for the ones who get it done.
This is SpaceTime, Series 28, Episode 109, for broadcast on the 10th of September 2025. Coming up on SpaceTime, solar flares over 6 times hotter than previously thought, understanding how the planet Jupiter's core was formed, and could life be evolving right now on our nearest exoplanetary neighbours? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown that massive explosions of energy blasting off the sun, known as solar flares, can reach temperatures of over 60 million degrees, some 6.5 times hotter than previously thought. The findings, reported in the Astrophysical Journal Letters, may provide an unexpected solution to a 50-year-old mystery about our nearest star. These dramatic events greatly increase the levels of solar X-rays and radiation reaching the Earth, and they're hazardous to spacecraft and astronauts, as well as affecting our planet's upper atmosphere. Solar flares heat parts of the sun's outer atmosphere, the corona, to temperatures of more than 10 million degrees. Now that compares to the sun's surface temperature of 6,000 degrees and its core temperature of about 15 million degrees. The new research examined evidence of how flares heat solar plasma, which is made up of ions and electrons. The study's authors argue that solar flare ions, positively charged particles that make up half of the plasma, can reach temperatures of more than 60 million degrees. The study's lead author, Alexander Russell from the University of St Andrews, says solar flares very likely heat the ions more strongly than they do electrons. Russell says recent discoveries show that a process called magnetic reconnection heats ions 6.5 times as much as they do electrons. And this appears to be a universal law, confirmed in near-Earth space, the solar wind, and in computer simulations. However, Russell points out that no one had previously connected work in those fields to solar flares. He says solar physics had historically always assumed that ions and electrons must have the same temperature. However, redoing the calculations using modern data, Russell found that ion and electron temperature differences can last for as long as 10 minutes in important parts of solar flares, opening the way to consider superhot ions for the first time. And the new ion temperature data fits in well with observations of the width of solar flare spectral lines, potentially solving an astrophysics mystery that stood for nearly half a century. See, there's been a long-standing question ever since the 1970s about why flare spectral lines, bright enhancements of the solar radiation at specific colours in extreme ultraviolet and X-ray light, are broader than they should be. And historically, this was believed to be caused by turbulent motions. But that interpretation came under pressure as scientists tried to identify the nature of the turbulence. And that's where the new work comes in. After nearly 50 years, it argues for a paradigm shift where the ion temperature can make a large contribution to explaining the enigmatic line widths of solar flare spectra. This is SpaceTime. Still to come, understanding how the gas giant Jupiter formed its core, and could life be evolving right now on our nearest exoplanetary neighbours? All that and more still to come on SpaceTime. The long-standing mystery of how Jupiter's core was formed has just been given a new twist, with fresh computer simulations suggesting a giant impact couldn't have created what astronomers are seeing. A report in the Journal of the Monthly Notices of the Royal Astronomical Society suggests a giant impact may not have been responsible for the formation of the Jovian core after all. It had been thought that a colossal collision with an early planet containing half of Jupiter's core material could have mixed up the central region of the gas giant enough to explain the interior we see today. But the new modelling suggests its makeup's actually down to how the growing planet absorbed heavy and light materials as it formed and evolved. Unlike what scientists once expected, the core of the largest planet in our solar system doesn't have a sharp boundary. Instead, it simply gradually blends into the surrounding layer of mostly hydrogen, forming a structure known as a dilute core. Now, how this dilute core formed has been a key question among astronomers ever since NASA's Juno spacecraft first revealed its existence. Before Juno, scientists speculated that Jupiter's core would simply be pure metallic hydrogen, but Juno's readings changed all that. Jupiter is the fifth planet from the Sun. It is nearly 2.5 times the mass of all the other planets in the solar system combined. Its diameter is some 11 times that of the Earth, and it's a full tenth the diameter of the Sun. Jupiter orbits the Sun at an average distance of 779 million kilometres, with an orbital period of 11.86 Earth years. Using new supercomputer simulations of planetary impacts, the authors tested whether a massive collision could have created Jupiter's dilute core. But the study found that a stable dilute core structure was not produced by any of the simulations conducted, even those involving impacts under really extreme conditions. Instead, the simulations demonstrated that the dense rock and ice core material displaced by an impact would quickly resettle, leaving a distinct boundary within the outer layers of hydrogen and helium, rather than forming a smooth transition zone between the two regions. The study's lead author, Thomas Sanders from Durham University, says it was fascinating to explore how a gas giant like Jupiter would respond to one of the most violent events a growing planet could ever experience. The simulations showed that this kind of impact quite literally shakes the planet to its core, just not in the right way to explain the interior of Jupiter as it's now understood. We now know Jupiter isn't the only planet with a dilute core. Astronomers recently found evidence that Saturn has one too. Now, the fact that Saturn also has a dilute core strengthens the idea that these structures are not the results of rare, extremely high energy impacts, but instead form gradually during the long process of planetary growth and evolution. This is SpaceTime. Still to come, could life be evolving right now on our nearest exoplanetary neighbours? And later in the Science Report, the new technology which will increase internet speeds by up to 45%. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, Insta360, the Go Ultra, a pocket-sized camera that's redefining how you capture life's adventures. Imagine it, a camera no bigger than an Oreo, weighing just 53 grams, yet packed with the power to shoot buttery-smooth 4K video at 60 frames per second. It's small enough to slip into your pocket, but delivers professional-grade footage that'll make your vlogs, travel diaries or family moments look absolutely stunning. And in terms of battery life, the Go Ultra's got you covered with a next-generation stacked polymer battery. The standalone camera runs for 70 minutes, and when paired with the Action Pod, you'll get up to 200 minutes of shooting time. If you need a quick recharge, we'll just plug it in and it'll hit 80% of charge in just 12 minutes. Just enough time to grab a coffee and get back to creating. The Action Pod's 2.5-inch flip touchscreen lets you frame shots, tweak settings, or even control the camera remotely for all those hard-to-reach angles. Storage is a breeze with removable micro SD cards supporting up to 2 terabytes, so you can shoot to your heart's content without worrying about running out of space. For stills, it delivers 50-megapixel photos packed with detail, perfect for everything from family snapshots to viral-worthy posts. And here's the best part. For the first 30 SpaceTime listeners who purchase the Insta360 Go Ultra at store.insta360.com, you'll score a free Sticky Tabs accessory to mount your camera on anything from backpacks to winter jackets. Just use the promo code SpaceTime at the checkout. That's store.insta360.com, promo code SpaceTime. Just go to our links page for full details and descriptions. So don't miss out on this titan of a camera that's ready to capture your world like never before. That's the Insta360 Go Ultra. And now it's back to our show. Scientists are speculating over the tantalising possibility that life could be evolving right now on some of Earth's nearest exoplanetary neighbours. The prospect of life beyond Earth and whether we're alone in the universe is one of those ultimate questions of science. When rocky Earth-like planets were first discovered orbiting in the habitable zones of some of our nearest stellar neighbours, excitement among scientists skyrocketed. That was until they realised that any hopes of life would be dashed by the high levels of radiation which would be bombarding these worlds. For example, Proxima Centauri is one of 3 planets in the Alpha Centauri star system, which is the nearest stellar system to the Sun. Scientists have discovered 3 planets orbiting Proxima Centauri. One of those, Proxima b, located some 4.24 light-years away, is a rocky Earth-like planet located within Proxima Centauri's habitable zone. That's the distance from a star, where it's not too hot and not too cold, but just right for liquid water, essential for life as we know it, to pool on a planet's surface. The problem is, Proxima b receives some 250 times more X-ray radiation than the Earth does, and could also be experiencing deadly levels of ultraviolet radiation on its surface. So, how could life possibly survive such a bombardment? Well, astronomers Lisa Kaltenegger and Jack O'Malley James from Cornell University believe they've got proof that life has already survived this kind of fierce radiation, right here on Earth. Their work, which was reported in the monthly notices of the Royal Astronomical Society, shows how life on Earth today evolved from creatures that actually thrived during an even greater ultraviolet radiation assault than what Proxima b and other nearby exoplanets are currently enduring. You see, the Earth of 4 billion years ago was a chaotic, irradiated hot mess. Yet, in spite of this, somehow life gained a foothold and then expanded. Kaltenegger and O'Malley James say the same thing could be happening right now on some of our nearest exoplanetary neighbours. To reach their conclusions, the authors modelled the surface ultraviolet environments of the 4 exoplanets closest to Earth that are potentially habitable: Proxima b, TRAPPIST 1e, Ross 128b, and LHS 1140b. Now, all these planets orbit small spectral type M red dwarf stars. Unlike our Sun, red dwarfs flare frequently, bathing any orbiting planets in high-energy ultraviolet radiation. Now, while it's unknown exactly what conditions prevail on the surface of the planets orbiting these flaring stars, it is known that such flares are both biologically damaging and they cause the erosion of a planetary atmosphere. High levels of radiation cause biological molecules like nucleic acids to mutate and even shut down. So O'Malley James and Kaltenegger modelled various atmospheric compositions, from ones very similar to present-day Earth to eroded and anoxic atmospheres, those with very thin atmospheres that don't block ultraviolet radiation well, and those without the protection of ozone. The models show that as atmospheres thin and ozone levels decrease, more high-energy ultraviolet radiation reaches the ground. The authors then compared their models to early Earth's history, from nearly 4 billion years ago through to today. Now, although the modelled planets all receive higher ultraviolet radiation doses than what's emitted by our Sun today, it's still significantly less than what Earth received 3.9 billion years ago. Kaltenegger says, given that the early Earth was inhabited, the research shows that ultraviolet radiation should not be a limiting factor for habitability of planets orbiting spectral type M stars. She says some of Earth's nearest neighbouring exoplanetary worlds remain intriguing targets in the search for life beyond our solar system.
My name is Lisa Kaltenegger. I'm the director of the Carl Sagan Institute here at Cornell, developing the forensic toolkit to find life in the universe, inside our solar system and outside. We live in this amazing time where we found thousands of other planets, planets that don't orbit our own sun, but other suns, other stars that you can see in the night sky. And the next one over after our sun is actually a small red star called Proxima Centauri, and even the next star, in only 4 light years away, has a planet that could potentially be like an Earth at the right distance, so it's not too hot and not too cold for there to be liquid surface water. So the big question that arose when looking at this young red sun is whether the harsh UV radiation that it flings out at its planet would actually be detrimental to life starting to evolve there. And what we figured out is when we calculated how much of this harsh UV radiation would make it to the ground on that planet, is that it would be worse than currently on Earth. So for you and me, it wouldn't be the best place to be, but it's less than it was on a young Earth. And on a young Earth, we had life. So the chances to finding life close to us, around the closest stars that happen to be red young suns, is much greater now. And so our quest to figure out whether we're alone in the universe just got a tiny bit easier.
That's Lisa Kaltenegger from Cornell University. And this is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new genetic study has shown that the first Australians arrived down under sometime around 50,000 years ago. The new findings, reported in the journal Archaeology and Oceania, analysed traces of Neanderthal DNA in Homo sapiens. The results are based on previous studies showing that Homo sapiens and Neanderthals interbred over a period of several thousand years, between 43,500 and 51,500 years ago. So, most modern non-African humans, and that includes Indigenous Australians, carry between 1 and 4% Neanderthal DNA. The new findings are also in general agreement with the latest archaeological data from across Australia, which points to the first appearance of First Nations in Australia in a range somewhere between 43,000 and 54,000 years ago. Overall, the findings contradict previous estimates, which suggested the arrival of the first Aboriginal Australians on what we call Terra Australis was 65,000 years ago, as a group known as the Sabul peoples. The seasonal outlook from the National Council for Fire and Emergency Services is warning that southwestern Victoria and patches of northern Western Australia are likely to face a heightened risk of bushfires or wildfires during this coming spring. The agency says the spring outlook has identified the Dampier Peninsula, the Derby Coast and central Kimberley, the Little Sandy Desert and the southeastern Pilbara region of Western Australia as areas of concern over the next few months. They also conclude that the southeastern agricultural regions of the Murraylands in South Australia and the south, southwest, central and parts of the Gippsland region of Victoria should also be at heightened alert during spring. New research has shown that transmitting the light through a hollow core optical fibre can actually speed up data transmission by as much as 45%. The findings, reported in the journal Nature Photonics, also show that hollow core fibre will allow data to travel further without the need of a boost. Regular fibre optic cables, such as the ones that might be connecting your home to the internet, rely on data being transmitted through a thin glass tube. The authors found that because their new design guides light through the hollow core of the fibre, it's travelling through air rather than being impeded by the glass. Also, current optical fibre cables lose about half of the light sent through them by the time they reach about 20 kilometres from the point of origin. Because of this, they need amplifiers to boost the signal at regular intervals. The authors say their new hollow fibres would let data travel 50% further before needing a boost, and that could open the door to much more data being transmitted without distortion. Samsung have used Europe's biggest tech show to launch their latest products. With the details, we're joined by technology editor Alex Harov-Royd from TechAdvice.life.
There's a big conference in Germany called IFA. This is the European equivalent of the CES show in Las Vegas or the Computex show in Taiwan. And there's been lots of technological announcements. Samsung made a number of announcements. Their one was to launch the new fan edition of its S25 range. This normally comes at this time of the year. It's the cheaper version of the flagship S25 series and comes a few months before Samsung launches its S26. Effectively, it has all the latest technologies but at a cheaper price, and it behoves interested parties to see if the actual S25 range itself has received any discounts on sales, because if you can get the full S25 or the Plus or the Ultra at a cheaper rate than you could when it launched in January, that would be better than the cheaper fan edition. So that's one of the things that people look out for this time of the year. Also, Samsung has the new S11, which is their tablet range. They have one in 14.6 inches and one in 11 inches. Last year they had one in the 12-inch size as well. They don't seem to have launched that mid-size model this year. These are, of course, very thin. They compete with the iPad that is, 5 millimeters thick. So Samsung, of course, has similar ambitions to, be very sleek and slim. But the other big thing that Samsung launched was a new micro RGB television technology, which is in 115 inches. So it's a giant size, something that's in between the QLED nano displays and the OLED display. So this is a third technology. It's just going to mean that there's more choice in the stores, more reason for you to want to spend thousands on a TV when some of the supermarkets sell, 80-inch TVs for under $1,000. And it's just the incessant progress and march of tech with AI and new technologies being the reasons why suddenly you have to spend more money.
That's Alex Zaharoff-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.